Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to study the rational expression. Generally, we know the rational form. What do you mean by rational form? Rational number P over Q. So, where Q is not equal 0. So, this is a condition for the rational number. Suppose an example, we will have 3 over 5 over 3 with 3 is not equal 0 minus 1 over 2. These are the rational number we studied in our P1, the real number system. Now here the rational expressions. So here we are going to study there is a polynomial. You will find it in the numerator as well as in the denominator. So you will have here x plus 1 over x minus 1. So this is a polynomial. You will find it in the numerator and denominator. This we call it as rational expression. And here also there is a restriction here. The domain of this is not equal to the denominator. X minus 1 not equal 0. If it is equal 0, it become undefined. So it is not equal 1. So the domain is defined as minus infinity plus infinity. It will take all the values of the real number except 1. So it will take all the values of the real number except 1. So it will leave 1. So this is the domain of the rational expression. So this is my domain of rational expression. Now here there is a simplify the rational expression. So you have to simplify this part by using the factorization. So in the numerator I have to factor this factor. So what is the factoring here? So the factoring in this term is it is 20. So what are the terms you can go with the factor? It is x minus 5 x plus 4. So if you multiply these two number, you will get what? If you multiply these two number, you will get minus 20. And if you add these two number, you will get minus 1. So therefore, it is factorized. Now the next one in the denominator, you have to go with the GCF. What is the common factor? So it is 3 is a common factor, x minus 5. So this is my factor. Now what are the cancel term? X minus 5 cancel. Therefore, the remaining terms you will have as x plus 4 over 3. So this is a simplified form. Now the next one, we will have a cubic term. So cubic expression in the numerator. So how are you going to solve these types of problem? Now here, this is actually, it is a power 3 and plus b power 3. What is b power 3? It is 25. Now it is 5 power 3 which is 125. So therefore I apply the a plus b whole a cube plus b cube rule in the numerator. So you will get x plus 5 and then it is x square minus 5x plus 25 over and what about the numerator denominator common, therefore you will have 2x is a common factor, you will get x square minus 5 and this can be written further as, how will you write this part? So this can be written as, let me check here. So if I take the 2x common, so you will get x square minus 25. Now this can be written as x minus 5, x plus 5. This part. Now what are the cancel term you have? 5 with the x plus 5 cancel. And it cannot be factorized further. Leave it as it is. So therefore the remaining terms you will have x square minus 5x plus 25 over this 2x is a remaining term. So what are the remaining term in the next? X minus 5. So we are applying the rule for this part. So x minus 25, which is equal x minus 5, x plus 5. So the remaining term you have to write it as it is. Now the next one we will have here. So how will you differentiate? How will you factoring this one? So what is the factor of this one? First I will do it this part, then we will do it this one. So if you multiply these two, so you will get here as 24. So I write it 3x square minus 20x minus 7. So it is 3x square. It can be solved by using grouping. So I have to use this rule. So it is minus, this is 21x, and then plus x for this part, and the remaining is minus 7. So it is actually here, if you multiply these two, you will get minus 21. What are the possible multiplier? 1 into 21, 3 into 7. Since it is both are minus, so I go with the large number minus. So I want to get it minus 20. The first one is the correct one. And by the way, the leading coefficient is not equal 1. Therefore, we have to go with the grouping. So 20x can be written as minus 21x plus x. Now, therefore, there is a common factor in these two terms. So it is 3x. So you will get x minus 7 plus 1 is a common in the second two terms. So you will have x minus 7. So x minus 7 is a common factor. 3x plus 1. 3x plus 1. So this is the first term in the numerator. Let us go with the denominator. So what is the denominator you have? It is 2x square minus 11x minus 21. So when you multiply these two part, you will get minus 42. So what is minus 42? You have 1 into 42, 2 into 21, 3 is possible. Yeah, 3 into 14, 3 into 14. Then 4 into, so 4 not possible. 5, 6, 6 is 36, 7 times. And since it is both minus, I say large number minus. So which one is correct in this case? So I want to get it minus 11. So you will get minus 14 plus 3. Now you cannot write directly because the leading coefficient is equals to. So therefore I will go with here minus 14x plus 3x, and the remaining will be the same. What is the remaining here? Minus 21 and 22x square. Now what is the common factor in these two terms? So therefore 2x. When I take 2x outside, the remaining term is x minus 7 plus, what is the common factor? 3, x minus 7. It should be same. Always in the grouping, you have to get the same term. X minus 7 here, then 2x plus 3. Now I got factorized. Now I just substitute in the rule. So what is the question here? The numerator part is this part. This is the numerator part. What is the numerator here? So it is x minus 7 and 3x plus 1 over. So over. What about the denominator? So this is the denominator. So it is x minus 7 into 2x plus 3. If you get cancel, if I cancel this part, you will get x minus 7, x minus 7 cancel. The remaining terms you will get 3x plus 1 over 2x plus 3. So this is the first form. So here the factoring is a very important technique to simplify the rational expression. Now here we will go to the next one. The two rational expressions are multiplied. Multiplication of the rational expression. So here also the same technique we have to follow. You have to factorize each and every term. After that, cancel and simplify. So this is the same technique we are going to follow. So what are the factorization of this part? So the first one is x minus 4, x minus plus 4. So this is the first part. Over. What about here? It is 1 into 12. So it is 12 means 3 into 4. X plus 4 and x plus 3. So this is a factor form of the first term. Now the next term. What is the next term here? We will have, so what is the multiplication? 1 into 27. So you will have minus 27. Which one is correct? 1 into 27, 3 into 7. So both big number minus. So you will have this part. I can write it directly. Why? The leading coefficient is 1. So here x plus 3 and x minus 7 over. And here there is a common factor x, therefore x minus 4. Now what is the cancel term? Plus 3, x plus 3 cancel, x minus 4 cancel, and there is x plus 4 cancel. And the remaining terms you will have it here, it is x minus 7 over x. So this is the simplified form of this rational expression. Now similarly here we will have another form. So you have to use this rule as y power 3 minus 2 power 3, a cube minus b cube. So what is the rule? A y minus 2 y square plus 2y plus 4 over. What about the denominator? It's a 6. So you have y plus 3 y minus 2. So when you multiply, you will get minus 6. When you add, you will get plus 1. So this is a short technique you can apply. Now in the numerator, y is a common, y plus 3 is the GCF, greatest common factor. And here in the denominator, what is the common factor in all? So it is a y. If I take it y outside, you will get y square plus 2y plus 4. Now what are the terms get cancelled after simplify? So you will get this, the whole term get cancelled. Now x y plus 3 is cancelled, and y minus 2 cancel. Therefore, and x y and y is also cancelled. There is a term only remaining which is 1 over 1. So in the numerator 1, denominator 1. So answer will be 1. So this is equal to 1. All the terms get cancelled. Now the next one we have going through, the before it was a multiplication, now it is a division of a rational expression. It is the same thing. Whenever you have a division, what we'll do? This is the technique we will follow for all the problems. So whenever you will have this part, so whenever you will have 5 over 3 divided by 1 over 2. So whenever we will have this part, so it is actually, you can write it, this one is divided by 1 over 2. It can be written as 5 over 3. I multiply. If I change the operation, I have to swap this number. Change this order. So it become 2 over 1. So this is the same technique we are going to follow in this case as well. So here we will do z square minus 1 and then over z square minus 16. I make this part as multiply. So this is a multiply and the fraction becomes reciprocal. It becomes reciprocal. So z square minus z minus 20. So this is the what you have. Now what is this one? It is a regular way what we have done before. So factoring here. So it is z minus 9, z plus 9 over, in the denominator z minus 4, z plus 4. The first part of is over. The next one here, if you multiply, you will get what? So this is 30, 36. So what is the multiplier here? Minus 36, 1 into 36, 2 into 18, 3 into 12, and 4 into 6. So small number minus. So we need here, and 36, it is 9 times. So 9 times. So small number minus. So therefore, you will get the last part. What is this one? If you multiply, you will get 36 minus 36. If you add, you will get plus 5. So therefore, it is z minus 4, z plus 9 over. And similarly, if I multiply with the 20, so you will get what? 20. 20 is 1 into 20, 2 into 10, 3 not possible, 4 into 5. So big number minus. So which one is correct? So the last one. So I write it directly because the leading coefficient is 1, z plus 4 and then z minus 5. Now what are the term get cancelled here? So you will have anything which is cancelled? Yes, it is z minus 4, z minus 4 cancel. After that, nothing is cancelled. Write it as it is. Because you will have z plus 4, z plus 4 both in the denominator. It's going to be not be cancelled. If it is in the numerator and denominator, then only cancel. So I write it here. Z minus 9 z plus 9 whole square over here z plus 4 whole square because it occurs two times. It is in the product and the remaining term is z minus 5. So this is the final answer. Now the next one we will have is the same rule. So I will just swap. So what happened here? I write it the x a plus 9 over a square minus 64. It's multiply. I change the operation, then you have to reciprocal this one. 5 plus a minus 24 over this is a cube minus 3a square plus 9a minus 27. So this is the second one. Now what happened in the first one? We don't have the formula for a square minus b square. That's why I will keep it as it is. You cannot factorize this term. But in the denominator, you can factorize. This is actually a minus 8. This is a plus 8. This is done. The first part is over. It is in the product. Now, what is the factoring in the numerator? So it is 1 into 24. So 1 into 24 is what? 1 into 24, 2 into 12, 3 into 8, and 4, 3 into 8, 4 into 6. So small number minus. So this one is correct. So if you multiply, you will get 24. If you add, you will get plus 5. So you have a minus 3 and a plus 8 over. And here you have to go with the GCF. What is the GCF here? What are the common factor in these two? So I will do it here, this part. So what is the common in these two terms? So you will have a square is common. A square is common. You will have a minus 3. And what is the common in this case? Plus 9 is common. So a minus 3. So you will get a minus 3 and a square plus 9. Therefore, you have to apply the grouping here. So after grouping, you will get a minus 3 is a one term and a square plus 9 is another term. So therefore, you will get this part. Now what is the cancel? A square plus 9, a square plus 9 is cancelled. A minus 3 cancel. And a plus 8, a plus 8 cancel. So the remaining terms you will have 1 over a minus 8. So this is the final answer. Now this is the multiplication and division has been done. The addition. Now the next one we have the addition concept, where we will have a denominator is going to be a same. When you have a denominator same, how will you simplify the fraction? The rational expression with the, it is a subtraction is there. If it is plus multiplication, we will directly multiply and simplify, but it is a minus. So how will you do this part? So it is the same story what we done before in the fraction. If you have a fraction with the same denominator, what we'll do? So we will just take as a one time and then we will just subtract. So this is the same technique we will going to follow. So this is equal minus 2. So we will follow the same rule. So here the denominator is going to be the same. So I will take the denominator as a one time plus 1. Now it is 5y minus 7 minus 2y minus 3. Now if you simplify, what will get? So it is over y plus 4. It is 5y minus 7. If you multiply inside the minus, minus 2y, minus into minus plus. So therefore, the y term. So y term is 3y. And then the constant term, add it, which is equal minus 4 over y plus 4. So this is the answer. Now similarly, in the next term, we will have the same denominator. Therefore, I will take the same rule, x plus 4 as a common factor. Therefore, x, and in between you will have a plus 7x. So if you add, you will get 8x over x plus 4. So this is the final answer. And many students are feeling you can cancel the y and x with the x. No, you cannot cancel, because the x in the denominator is along with the plus 4. If it is no 4, you can cancel, but it is a 4, leave it as it is. Now the next one, the last type of this problem in this chapter, which is the different denominator. So plus, you will have a different denominator. So whenever you will have a different fractions, how will you add it the fractions? Suppose if you have a 3 over 5, how will you simplify this one? We will do it, just multiply first the denominator, which is 10. After that, cross multiply. So this is the same rule we will apply. 5 into 1, 5, it is 6. So answer will be 11 over 10. Same rule we are going to follow in order to simplify this rational expression. Now here, see this denominator, the denominator is different. So here you will have x minus 5, x plus 3. But in the last problem, if you see the last case, you will have a same denominator. That's why we will take as a same in the denominator. Now here we are multiplying. We will use the same rule. We will use the same rule here. So this is a solution. You have x minus 5 and x plus 3. So when you cross multiply this part, I have to multiply x with each term. When you multiply each term, you will get x into x square plus 3x. And the next one, I have to multiply this part. 7x, I have to multiply each and every term. What happened? 7x into x, which is 7x square. Then plus into minus 35. This is square, 35x. Now simplify. So what is the simplify here? So added the same identical terms. Square terms, you have 1 plus 7, 8x square. And then we will have an x term, which is minus 32x over x minus 5, and then x plus 3. And similarly, here you can factorize the numerator further. How? So what is the common factor in the numerator? It is 8x. If I take a 8x common, you will get x minus, this is 4, over x minus 5 and x plus 3. So it cannot be cancelled. Leave it as it is. So this is a simplified form of the rational expression. We will solve one more problem in the similar case where we have a different denominator. So we will go with the same rule. So this is y minus 1, 3y minus 1. When I multiply this part, what happened here? This is actually a plus b, and this is what? A minus b. So the rule is what? A square minus b square. So you will have 3 square, 3y square is what? 3y square minus 1 square, which is 9y square minus 1. So I write it here, 9y square minus 1. When you cross multiply this part, you have to multiply each and every term. So take the 2y and multiply both the terms. So you will get what? 2y square minus 2y. This is done. Now I will take the 1 and multiply with the both the terms. So you will get plus y minus 1. Now simplify. So what is the simplification here? So y square terms, you have two terms. This is 11y square. Next, y terms, you will have two terms, which is equal minus y. And the constant, which is minus 1, minus 2 over. And then you have y minus 1. Then y minus 1. And then 3y minus 1. So this can be done in this form. Thank you.